Hello and welcome back to this series on shapes, and in this episode I'm going to look at Pythagoras Theorem and how it can be used to calculate the height of a triangle. If you've been watching the previous videos in the series, you'd have seen that I quite often divide shapes up into triangles, and in order to find the area of a triangle I also need to find the height. So this is okay if you have a right angle triangle because the height will be the vertical side. However, if we have something like a isosceles or an equilateral triangle, the height becomes a little bit more difficult. However, you can always divide a isosceles or equilateral triangle down the middle to turn it into two right angle triangles, which then you can calculate the vertical from by using Pythagoras Theorem. Pythagoras Theorem is probably the most famous mathematical theorem there is, and it follows this form of a squared plus b squared equals c squared, or the square of the hypotenuse, which is the long side of the right angle triangle, is the sum of the square of the other two sides, which is what this is showing here. You have c, which is the hypotenuse, that's the long side, a and b are the other two sides, and we're summing those together, but we're squaring them. This means that if we wanted to find the length of c, we have to square root the c squared to make it into a c, and therefore we have to square root the a squared plus b squared. Please note that a squared plus b squared square rooted is not the same as a plus b. So Pythagoras' theorem relies on us knowing two sides of a right angle triangle to be able to find the third side. In next week's episode we'll be looking at trigonometric functions such as sine, cosine and tan, when we know one side and angle to be able to find the other two sides or any other angle. But back to today, if we were wanting to say find the height of this triangle, we could rearrange this first equation so we end up with b is equal, we can take the a squared over to the other side and it will become minus, and then square root all of that. So this is how we can use Pythagoras' theorem to calculate the height of a triangle. And as I say, it relies on us knowing two lengths of the right angled triangle. The big question is, where does this formula come from, and can we show that it always works? As with most things in maths, there are numerous ways of showing how a formula can be come up with. I'm going to show a visual way. So what I want you to imagine is that we take our triangle, and we're going to take this triangle and move it around and multiply it or come up with it 4 times. So what I'm going to do is draw another triangle. I'm going to do it in red. In which case this side is still going to be C, this side is now A, that's B. And then I'm going to draw a third triangle. That's A, this is B, this is C. And finally I'm going to draw a fourth triangle here. And I've labelled them all up. So all these triangles are equal, they've just been rotated around 90 degrees each time. And as you can see, we have a square in the middle. So if you look back at my video on quadratic equations, we're going to need to use something from that, which is expanding the bracket to calculate the area of this big square. So the area of this big square is A plus B all squared, because we've got length of A plus B, and to square it we have to square that term. And this is going to be equal to the area of these 4 triangles plus the area of this inner square. So the inner square has lengths of c, so the area of that inner square is c squared, and we can add to that the area of these four triangles. So we need 4, and that's going to be multiplied by half the base times the height of each of these triangles. So we can have half AB. We can now expand this bracket. So when we expand this bracket, we have an A times an A, which I shall do it like this so you can see it. So we have A times A, which is A squared, B times B, which is plus B squared, A times B plus B times A, which is the same as AB. So the area of this square is equal to A squared plus B squared plus 2AB is equal to C squared. 4 times a half is 2 AB. As you can see, this 2AB will cancel with 2AB, this 2AB, and we end up with A squared plus B squared equals C squared, which is Pythagoras' theorem. So we got around to showing that this actually does work. So as I say, in next week's video we will look at how to find the lengths of the sides of triangles using trigonometric functions. So hopefully you enjoyed this video and found it useful, and I'll see you again next week.